Once again, we have our friend Anne. How much work would it take to stop a vehicle? So again, my first thought would be, well, work is force times distance. Don't see a force, don't see a distance. It's also the area under a force versus distance graph. By the way, I can remember because work is force times distance. That's also the same graph, force versus distance. Oh, no good. Okay, this is also going to be the change in potential plus the change in kinetic. I don't see any mention of a hill here, so I'm going to assume that it's going to be KE final minus KE initial. And I guess because it says stop, KE final is going to be 0. I get this. Work equals negative a half m v initial squared. It's going to be negative 0.5 950 45 squared. Why negative? It's telling me the car has to lose energy to come to a stop, which it does. Now that energy doesn't vanish, it's got to go somewhere, goes into heating up the brakes. I get negative 962,000. Just remembered, I forgot to bring out one of my favorite work energy toys. Going to pause the video for a second. After that little diversion, let's keep going. If it takes 150 meters for the vehicle to stop, what's the minimum force of friction? Well, I mean, at first I thought, well, friction is mu times the normal force, but I don't see a mu. I could maybe do a free body diagram, but what did I find in part A? I found the work done in bringing it to a stop. What's doing that work? Friction is. So I actually started out by saying, oh, work equals work. Negative 962,000, although I'm going to use my answer button, equals negative force of friction times distance. Why negative on the right? Because the distance and friction are in opposite directions. The negative's going to cancel out. And I said, oh, I can figure out the force of friction. Just divide by d. Friction is going to be 962,000, answer button actually, divided by 150. It's going to be this number divided by 150, but I'm going to ignore the negative that showed up. So 6,410 newtons. What's the minimum coefficient of friction? Oh, now I can do something with this, because friction is also mu times the normal force. I guess mu is going to be friction divided by the normal force. I don't know the normal force, but you know what? We're in grade 12 page. We've gotten pretty good at free body diagrams. I'm just going to imagine, I'm pretty sure mg and the normal force, oh, but look. I think they're the same thing. I'm pretty sure. So I think I can go 6,410. I'm going to use my answer button, divided by mg, divided by bracket 950 times 9.8. Ignoring the negative because I didn't clear the negative out. 0.689 units for mu are none. Why do I keep saying minimum and minimum? Well, you might have more to spare. This would be, if you were hitting the brakes like this, you would feel through the steering wheel. You were almost ready to start skidding. You would be very uncomfortable if you were driving. Ideally, you'd have way more, and we're in a nice controlled stop. RCMP officer is investigating an accident. Car has struck a pedestrian. We want the minimum initial safe speed. This is the full-fledged version after Physics 11 when I had to have the cell phone pick up the sound of the skid. I don't know if you remember, it was one of the first questions I did with you in the kinematics unit. I mean, as if the cell phone's going to pick up the sound of the skid. What a cop-out was that? No, we can do it. But we start out by saying, again, work equals work. We're going to say force times distance equals the change in potential plus the change in kinetic. I don't see any hint of a hill, and I'm not going to give you a hill on your test, but it wouldn't be that hard to include it. Oh, how high is the hill? There's my MGH initial and MGH final, and away I go. I'm going to get force times distance equals a half mv final squared minus a half mv initial squared. But wait a minute, I know v final of any car accident ever is 0. Oh, I also know that the force and the distance are in opposite direction. Both sides are going to be negative. In fact, the negative is going to cancel out. And it wants me to get the v by itself. I can do that. V is going to be 2 times the force of friction times distance divided by m square root. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. It's going to be mu m times g times d divided by m. Conveniently, the m cancels. I could have canceled out the m on another line as well, but it does cancel out. And I end up with the minimum speed must have been 2 times 0.55 times 9.8 times 52. Oh, divided by nothing. 2 times 0.55 times 9.8 times 52. That's way too fast. Oh, square root. And I get 23.7 meters per second. If you got that, I would give you 3 out of 3. Otherwise, I can't help noticing I kind of wrote 6 lines. I would probably go half mark if I saw that. Half mark for that, half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. A child on a water slide passes point A at 8.3. How fast is, if we ignore friction? There's a change in height, change in speed. This is a good job for conservation of energy. G. I'm going to let the ground be this dotted line, even though technically the ground is probably the actual surface, cement surface of the pool. I'm going to do that. This is going to be a half m v initial squared plus m g h initial equals a half m v final squared. You know what? Turns out if we're ignoring friction, not only do masses cancel out on roller coasters, but they cancel out on water slides too. Little kids and grown-ups can go together. Yay. I want to get the v final by itself. I'm going to do one more thing. I'm going to go times by 2, times by 2, times by 2, because that's going to cancel that 1/2 and that 1/2, and that's going to leave me with vi squared plus 2gh initial equals vf squared. And how do I get rid of a squared? I square root. Vf is going to be the square root of Vi. It was 8 point something, wasn't it? 8.3 squared plus 2 times 9.8 times 21. Square root bracket 8.3 squared plus 2 times 9.8 times 21. Did y'all get 21.9 meters per second? If you got that, 4 out of 4. Otherwise, I would probably give you 1 mark for that line. I would probably give you 1 mark if I saw that, 1 mark for the numbers, 1 mark for the answer. What if they're only traveling 16 meters per second? Okay, Ke initial plus Pe initial equals Ke final plus heat. I looked at the previous question and I said, you know, PE final is going to cancel out. So Mason, I was too lazy to even bother writing it out. How would I get the heat by itself? Divide by KE final? No, subtract. So heat is going to be, let's do it in black, Mr. Duke. Heat is going to be initial plus initial minus final. Heat is going to be 0.5 times M times V initial, which was, well, I'll just write V initial squared, plus MGH initial minus a half MV final squared. I don't know why I wrote this in brackets. I was like it was numbers. Let's just go a half MV initial squared. Now let's plug in numbers. Heat is going to be 0.5 times, ooh, the M doesn't cancel this time because there's no M in heat, 45 times 8.3 squared plus 45 times 9.8 times 21 minus 0.5 times 45 times 16 squared. 0.5 times 45 times 8.3, don't forget the squared, plus 45 times 9.8 times 21 minus 0.5 times 45 times 16, don't forget the squared. Do y'all get 5,051 points? I'll go 5,050. 50-50. If you got that, 4 out of 4. Otherwise, I would give you 1 mark for that. Probably give you 1 mark for that. 1 mark for the numbers, and 1 mark for the answer. Probably something like that. Another roller coaster. This could do it. This is a fun quiz. Yes, it is. We've done water slides. Now we're on a roller coaster. Oh, this is excellent. What's its speed at the bottom of the hill? Okay. This one's actually pretty nice because the final potential and the initial kinetic are 0. And you just end up with mgh initial equals a half mv final squared. And hey, even the m's cancel. You end up with vf at the bottom equals 2gh initial square root. It ends up being the square root of 2 times 9.8 times 90. I think this works out even. Is it 40? 42? 42. Okay. Dead even, right? In fact, I gave you one like this in the notes, and I picked the same template, and I changed the mass thinking, oh, that'll give them a different answer. Did changing the mass give you guys a different answer? Yeah. I don't know. Probably. Thank you. I owe you candy. We got the same answer when we did the same hill in our notes with a different mass because the m's canceled. How fast will the coaster be traveling at the top of the next hill? So you got that 2 out of 2, by the way. Otherwise, I'd probably go half mark for that, probably a half mark for that, half mark if I saw that, and a half mark for the answer. I'm going to choose to let the ground be here. So I'm going to let initial be here, final be here, and a height of 0 be at the top of the second hill. Because then I can go like this again. K-E initial and P-E initial, K-E final plus P-E final, but P-E final is 0 again. Oh, and K-E initial is 0 again. In fact, I end up with pretty much the same thing. MGH initial equals a half MV final squared. I end up with V final equaling the square root of 2GH initial. It's going to be the square root of 2 times 9.8, but not times 50. Times what? Or not times 90, 40. 2 times 9.8 times 40. This, I think, also works out evenly. 28. On the test, they probably won't work out evenly because I don't care enough about you to do that. For 3 marks, I would give you 1 mark for that. I would probably give you a half mark if I saw that. Half mark for that. Half mark for the number. Half mark for the answer. Ooh, a bow. How much work? Okay. Work is going to be force times distance. So obviously it's going to be 130 times 70. Is that correct? 0.7. 130 times 0.7. And I've done 91 joules of work. How much potential energy is stored in the bowl? 91 joules of work. Not MGH. There are other types of potential energy besides just gravitational potential energy. If the arrow has a mass of 18.6.0186 kilograms, nice try, Duick. What's the maximum speed? I'm going to argue that that 91 joules gets turned into a half mv squared, turns into kinetic. I could have done a full conservation of energy equation, KE initial PE, forget it. All of that 91 is getting turned into kinetic. So I think the final speed is going to be 2 times 91 divided by 0.0186 square root. 2 times 91 divided by 0.0186 square root of that. And I get 98.9, which again seems to me fairly reasonable, especially if it's a good compound bow. An arrow taking about 1 second to travel a football field, yeah, it would be a streak, but I could kind of follow it with my eyes, and that's my experience when I've seen arrows shot either in real life or on TV. They're not bullet fast where you don't see anything, but they're not like throwing a baseball fast where you can clearly follow it with your eyes. They're somewhere in the middle. That's about right. Suppose the arrow only leaves the speed, or leaves with a speed of 54. How much energy was lost to heat? Okay. I guess I would say this, that 91 joules is a half mv final squared, but some of it went into heat. So the heat is going to be 91 minus 0.5 mv final squared. It's going to be 91 minus 0.5 times 0.0186 times 54 squared. 91 minus 0.5 times 0.0186 times 54. Don't forget the squared. 63.9? Joules of heat. So it's possible on this quiz to get 24 out of 23.